According to the National Electrical Code, all water heaters must be electrically bonded to the electrical panel. This ensures a proper path for any stray electrical current to flow, reducing the risk of electric shock or fire. When a haircutting salon, for example, installs its own water heater and taps into an existing water line within a larger building like a department store, it's crucial to understand the bonding requirements. The haircutting salon is responsible for installing and maintaining its own water heater. However, because they are tapping into the store's water line, they must also ensure that the water heater is properly bonded to the store's electrical panel. This bonding is not merely a suggestion, but a mandated safety measure outlined in the NEC. The bonding connection must be made using a copper wire sized according to the NEC standards. To determine the correct size of the copper wire, refer to NEC Table 250.102 cone if it is the grounding electrode conductor, or 250.122 if it is the equipment grounding conductor. The wire should be connected securely to the water heater's bonding lug and the electrical panel's grounding bus bar. The purpose of bonding is to create a low impedance path for fault current. In the event of an electrical fault within the water heater, such as a short circuit to the metal casing, the fault current will flow through the bonding conductor back to the electrical panel and trip the circuit breaker. This rapid tripping of the breaker disconnects the power supply and minimizes the risk of electric shock to anyone who might come into contact with the water heater. Without proper bonding, the fault current might find an alternative path to ground, potentially through a person touching the water heater and a grounded object, resulting in a dangerous electrical shock. The NEC specifies that the bonding conductor must be sized appropriately to handle the potential fault current. Using a wire that is too small can result in the wire overheating and potentially melting, which would negate the safety benefits of the bonding connection. Ensuring the bonding connection is tight and secure is also paramount. A loose connection can create resistance in the circuit, which can impede the flow of fault current and reduce the effectiveness of the bonding system. Periodically inspecting the bonding connection to ensure that it remains tight and corrosion-free is advisable. Corrosion can also increase the resistance of the connection. Proper grounding and bonding are fundamental principles of electrical safety. Grounding refers to connecting the electrical system to the earth, providing a reference point for voltage and helping to stabilize the system. Bonding, on the other hand, involves connecting non-current carrying metal parts of the electrical system to create a continuous electrical path. Together, grounding and bonding work to minimize the risk of electric shock and fire. In the specific scenario of a haircutting salon installing a water heater in a department store, it is the responsibility of the salon's electrical contractor to ensure that the water heater is properly bonded to the store's electrical panel. The electrical contractor should be familiar with the NEC requirements for bonding and grounding and should perform the work in accordance with those requirements. The local electrical inspector will typically inspect the work to ensure that it meets the code requirements. The inspector will check the size and type of bonding conductor, the tightness of the connections, and the overall quality of the installation. Failure to properly bond the water heater can result in a rejection of the electrical inspection and potentially hazardous conditions. It's important to note that bonding requirements can vary depending on the specific installation and local codes. Consulting with a qualified electrical contractor or electrical inspector is always recommended to ensure compliance with all applicable regulations. When making the bonding connection to the water heater, it's important to clean the surface of the metal to ensure good electrical connection. Remove any paint, rust, or other debris that could interfere with the connection. Applying an antioxidant compound to the connection can also help to prevent corrosion. The bonding conductor should be run in as straight a line as possible, avoiding sharp bends or kinks. Sharp bends can increase the impedance of the conductor and reduce its effectiveness. The bonding conductor should also be protected from physical damage. If the conductor is exposed to potential damage, it should be run in conduit or otherwise protected. In addition to the bonding conductor, the water heater itself should be properly grounded. This is typically accomplished by connecting a grounding conductor from the water heater's metal casing to the electrical panel's grounding bus bar. The grounding conductor provides a path for fault current to flow back to the electrical panel in the event of a ground fault within the water heater. Regular maintenance of the water heater and its electrical connections is essential for ensuring continued safety. Periodically inspect the water heater for any signs of corrosion, leaks, or other damage. Check the bonding and grounding connections to ensure that they are tight and corrosion-free. If any problems are detected, they should be corrected immediately by a qualified electrician. Remember that electricity can be dangerous, and it's always best to err on the side of caution. If you are not comfortable working with electricity, it's best to leave the work to a qualified professional. Working with electricity requires knowledge, skill, and experience. Attempting to perform electrical work without proper training can be hazardous and potentially life-threatening. In summary, bonding a water heater that taps into an existing water line is a critical safety measure required by the NEC. Proper bonding ensures a low impedance path for fault current, reducing the risk of electric shock and fire. It is the responsibility of the installer to ensure that the water heater is properly bonded in accordance with all applicable codes and regulations. Consulting with a qualified electrical contractor or electrical inspector is always recommended to ensure compliance and safety. The bonding conductor should be copper, sized according to NEC Table 250.122 based, and the overcurrent protection device protecting the circuit. It should be connected to the water heater's bonding lug and the electrical panel's grounding bus bar. The connection should be tight, secure, and free from corrosion. Regular inspection and maintenance of the water heater and its electrical connections are essential for ensuring continued safety. Always prioritize safety when working with electricity, and if you are not comfortable performing the work yourself, consult with a qualified professional. The NEC is updated regularly, so it's important to stay current with the latest requirements. Local jurisdictions may also have their own specific codes and regulations, so it's important to check with the local authorities to ensure compliance. Proper bonding not only protects individuals from electrical shock, but also helps to protect the electrical system from damage. By providing a low impedance path for fault current, bonding helps to ensure that the circuit breaker trips quickly and effectively, preventing damage to equipment and wiring. In addition to water heaters, other metal objects that are likely to become energized should also be bonded. This includes metal pipes, metal ducts, and metal enclosures. Bonding these objects helps to create a comprehensive electrical safety system that protects against a wide range of potential hazards. The grounding bus bar in the electrical panel is the central point for all grounding and bonding connections. It is typically a copper bar that is securely connected to the building's grounding electrode system. The grounding electrode system provides a connection to the earth, which helps to stabilize the electrical system and provide a path for fault current to flow back to the source. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The specific requirements for the grounding electrode system are outlined in the NEC. When installing a grounding electrode system, it's important to follow the NEC requirements carefully to ensure that the system is effective and safe. The grounding electrode system should be inspected regularly to ensure that it is in good condition and that the connections are tight and corrosion-free. In addition to the NEC, other standards and regulations may also apply to electrical installations. These may include standards from organizations such as Underwriters Laboratories UL and the Institute of Electrical and Electronics Engineers IEE. Compliance with these standards helps to ensure that electrical products and installations are safe and reliable. Electrical safety is a shared responsibility. Everyone who works with electricity should be aware of the potential hazards and take steps to protect themselves and others. This includes following safe work practices, using appropriate personal protective equipment, and reporting any unsafe conditions. Education and training are essential for electrical safety. Anyone who works with electricity should receive adequate training on safe work practices and the proper use of electrical equipment. Regular refresher training is also important to ensure that workers stay up to date on the latest safety procedures. By working together, we can create a safer electrical environment for everyone. Remember to always consult with a qualified electrical professional for any electrical work. Electrical work can be dangerous and should only be performed by those who are properly trained and experienced. Do not attempt to perform electrical work yourself unless you have the necessary skills and knowledge. Always prioritize safety when working with electricity, and if you are unsure about anything, ask for help. Proper bonding and grounding are essential for electrical safety, and it's important to understand the requirements and follow them carefully. By taking these steps, you can help to protect yourself and others from the hazards of electricity. Remember that electricity is a powerful force, and it should be treated with respect. Always be aware of the potential dangers and take steps to protect yourself. If you have any questions or concerns about electrical safety, consult with a qualified professional. They can provide you with the information and guidance you need to stay safe.